All right, hi guys. Today we're looking at angle properties in triangles. So the last couple of lessons we've been looking at basically just different justifications that we have for finding the measurements of angles in certain situations, mostly with transversals and parallel lines. And today we're going to kind of take that a step further by starting to look at how those properties apply to different types of polygons. So we're going to start out with triangles, and then we're going to move into some other types of shapes. So we'll start out with an example that basically looks at how we can start integrating the angle properties that we've looked at into a triangle type of a shape. So in this diagram we have angle MTH is an exterior angle, so going MTH, and they have given us the measurement of 155 degrees. So it's an exterior angle of triangle, so just get used to that symbol. We've already been familiar with the symbol for the angle. When you see this symbol, pretty obviously it means triangle, MAT. So determine the measures of the unknown angles in triangle MAT. So we're given one of the interior angles, and that's it, other than this exterior angle. So what would be one of the first things we can look at? Well, we have this 155 degree angle here, and what do you remember from your different types of angles? What could you do with this angle here? Well, we know that angles that are on a line like this add up to 180 because they are, try and think if you can remember the name, MTH and so angle MTH and angle ATM are, the word you were hopefully came up with is supplementary, right? And we just know that that means that they add up to 180 degrees. So basically then we can say that angle ATM then would have to be equal to 180 degrees minus the second component there, which is the 155 degrees, which is going to be equal to 25 degrees. Okay, so now we have a measurement for one of the angles inside of the triangle. How can we find this last angle here, angle MAT? Well, we haven't looked at anything yet that would help us out, so this is where we're going to branch into some new information, although hopefully it's not new to you because you should have done this before in your math past. So basically we know that all angles in a triangle add up to what? 180 degrees. So it's just kind of like those supplementary angles. And so then we can say that angle MAT is going to be equal to, the total for all three angles has to be 180 degrees. And we need to take off the two angles that we already have. So we know that one of them is 40 and the other one is 25 degrees. Okay, so 180 minus 40 minus 25 leaves us with 115 degrees for angle MAT. And so that's how we're able to solve for all the angles in a triangle. So just keep in mind this new kind of piece of information, or reminder rather, that all the angles in a triangle add up to 180. And we can actually use that as one of our justifications when we have one of these tables set up kind of like this. So basically you would say in your justification, there's variations on it. Some people just say like sum of triangle. I usually write like angles in triangle equal 180. Now the other piece of vocab we need to know before we move on to more examples is non-adjacent interior angles. So what we're talking about with non-adjacent interior angles is when you have a setup kind of like this, where you have the triangle that's attached to further angles on the exterior of the triangle. Non-adjacent interior angles, as the name kind of implies, they're interior, so that means they're inside of the triangle. So right now, just knowing that, it could be angle A, angle B, or angle C, or all three. But the trick with this one is that it can only be two angles of the triangle, and they cannot have the same vertex as an exterior angle, which sounds a little bit tricky, but basically all that means is if you think about angle C here, vertex just means like the point where the angle kind of makes the like a sharp point there, so that's the vertex. And this is shared with, so the angle C here shares this point with this angle here, angle ACD, right? They have a point in the angle right there. So this angle C cannot be a non-adjacent interior. So then that means that our non-adjacent interior angles are going to be angle angle A and angle B. Okay, because they're not connected to any exterior angle. So just make sure you're aware. There's only ever going to be two angles if you have one of these external connections, and they cannot share the same vertex as the exterior angle. Okay, so now that we know that, let's try some examples. In this first one, we're asked to prove that angle E, so this one here, is equal to angle A plus angle B. Okay, so let's start out by thinking about what could we say angle E might be equal to if we start at this part of the proof. So angle E, if we look right away, the adjacent angle to it is this angle C, and what kind of relationship do those two angles have? Well, as we just saw in the previous example, you probably recognize right away that those are supplementary angles because they're on a straight line. So even though we don't have a measurement for angle C, or actually any of the angles in this triangle, we can just make a general statement by saying that angle C plus angle E are going to equal 180 degrees. Now what we kind of want to have is we try to want to set up statements that kind of resemble what we see here. So we just want to have an angle E on its own and say what is it equal to. Well, angle E is going to be equal to, if we move C to the other side, it's going to be 180 degrees minus angle C. Okay? And our justification for that is just supplementary. Okay. Now, what other things do we have to prove? Well, angle A plus angle B, we need to set those equal to something. So if we look inside of this triangle, angle A plus angle B doesn't really give us much of anything, but if we say angle A plus angle B plus angle C, what do those three angles add up to? Well, we know they add up to 180 degrees. So we can say angle A plus angle B plus angle C are going to be equal to 180 degrees, right? And if we want to do the same thing as we did up here, which is just to isolate this section, angle A plus angle B, then it's going to be equal to, again, 180 degrees minus C. Okay, and so this is where we would put in that proof that I was talking about earlier, where I would say angles in triangle equal 180 degrees. So I like to use the shorthand for this one. If you're on a test or anything like that, you can totally write that out and I will understand what you mean. Or you can feel free to write the word version as well. Okay, so now if we look at what we have here, angle E is equal to 180 degrees minus C. Angle A plus B are equal to the same thing. So what does that tell us about the relationship between angle E and angles A plus B? Well, remember that we had that thing called the transitive property, which tells us that if one thing is equal to another and another thing is equal to that same thing, then those two things have to be equal to each other. So that was called the transitive property. And so we can say if E equals 180 degrees minus C and A plus B equals 180 degrees minus C. Sorry guys, I've forgotten to write in my angle signs again, but whatever. Then angle A plus angle B equals angle E. So I kind of reversed it from what it says up here, but same thing. So, and the reason for that is the transitive property. Okay, so now we've been able to prove that using our different justifications. So let's move on to another example here. So in this one, it asks us to determine the measures of NMO, angle NMO. So that's going to be, sometimes I like to, just so I can keep track of what they're asking me for here, NMO. So basically we want this one here. What else do they want? They want angle MNO. Okay, so they also want, try and draw that on the inside here. MNO. Okay, and then the other thing we want is angle QMO. So it's going to be like this. Okay, hopefully those colors didn't all blend together too much. But basically, let's start by looking at what we have. So the first one they said was NMO. Now if I look NMO here, I don't have a lot of information. I have this 67 here, and I know that 67 is going to be supplementary if I go all the way over to the other side of this flat line. But the problem with that is that I actually have two more angles here, and I can't solve for two angles, like two unknowns, if I don't have another factor there. So what I might do is skip this one to start out with, and you'll have to kind of be aware with that as you go through tests and things like that. Just because they list an angle first of all doesn't always mean that it's going to be the best one to start with. So I'm going to look at MNO and see if that's any easier to solve for. So MNO, well, with that one, I have a little bit more information because I have a 20-degree angle here. And the other factor that I have is this 67 here. So remember that we have, maybe I'll just take this minute to do a quick refresher of the different proofs that we have. So supplementary, we've already been over. We're not working with complementary today. The other things we have to work with are alternate interior, alternate exterior, corresponding angles, and opposite angles. So out of these ones, which one do you see in this section? If we're trying to look at this angle here. Well, you might see that we've got two parallel lines running here, and then we have a transversal here. Here we have 67 degrees, and it's on the interior, and the angle we're looking for is on the other side of the transversal, but also on the interior of the parallel lines. And so what we're looking at here is alternate interior. Now the only problem is that 67 degrees here is going to be equal to 67 degrees from the transversal all the way to the straight line. And so all we need to account for is that if this whole thing is 67, this component that we're actually looking for is going to be 67 minus this 20 degrees, okay? And so we just need to account for that in our math. So we're basically going to say angle MNP is equal to 67 degrees, and that's because of our alternate interior. And then, so angle MNO is going to be the 67 degrees minus the component that was put in there, which was the 20 degrees. And that gives us a total of 47 degrees. Okay, and our justification for that is alternate interior. Okay, now what else did we have? Okay, so we've solved for MNO. Let's try QMO before we go back to the first one. So QMO is this little one here. Actually, it might be better to go back because now we're in that same situation. If we start trying to solve this one where we don't really have, if we had this angle, it would help us out. And actually, now that I think about it, if we have angle NMO here, so we're looking for this one now, then what do we know? Well, if we look here, we can see the shape of a triangle. And we just learned in the previous page that all the angles in a triangle add to 180. We've solved for this angle here. That one is 47 degrees. Right? So now we can solve for this last one. So we can say angle NMO is going to be equal to 180 degrees, which is the sum for the triangle, minus 47 degrees minus 39 degrees. So angle NMO is equal to 94 degrees. Okay, and again, we can use that proof, angles in triangle equal 180 degrees. All right, so now we just have this last one here, and since we've kind of already thought about this, we can probably figure out where we're going to go with that, which is that 67 plus this angle we just solved for, which was 94, plus this QMO are supplementary, so they have to add up to 180. So we can say angle QMO is going to be equal to 180 degrees is the total, but we need to subtract off our known values, which is 67 degrees and 94 degrees, which is going to leave us with 19 degrees. Okay, and our justification for that was that those are supplementary angles. Okay, all right. So the last part here is just a little bit of a reminder, so a summary of some of the different proofs we've looked at. So first of all, in any triangle, the sum of the measures of the interior angles is 180. So basically, if you have angle A plus angle B plus angle C, they're going to equal 180. So that's written right down here. Now the other component here is that the measure of any exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles, which is something that we haven't done calculations with really, but it is a good thing to know. So basically what we're saying is we have non-adjacent interior angles. If we look at this triangle, see if you can identify which ones are non-adjacent interior angles. Well, you should have guessed A and C, because they are angles that are inside the triangle that are not connected to any exterior angle. Angle B here has this angle making it supplementary, so it cannot be a non-adjacent. So basically what they're saying is the measure of any exterior angle of a triangle, so that would be this one here. Maybe let's highlight this. Okay, so we have an exterior angle, and that's going to be right here. So angle B. Okay, is going to be equal to the sum, so remember, sum always means adding, sum of the two non-adjacent interior angles. So basically that's going to be this one plus that one. Okay, so if we add these two together, then we get the the value for this exterior angle. Okay, and that's everything for today. So you guys have a little assignment to try out of the textbook there. And next time we will be looking at scale factors in areas of two-dimensional shapes. Okay, so I will see you then.